In this video, we will look at arithmetic series. We get an arithmetic series when we add together the terms of an arithmetic sequence. For example, we could have an arithmetic sequence. We sometimes call an arithmetic sequence an arithmetic progression. Sometimes we just call them an AP. So if the arithmetic sequence or the arithmetic progression is something like 3, 5, 7, 9 and so on, then the arithmetic series is 3. Then the next term is the 3 plus 5, so that's the 8. Then we add on the 7. Then we add on the 9 and so on. We use T1, T2, T3, etc. for an arithmetic sequence. Or arithmetic progression. And we use S1, S2, S3 and so on for the terms of an arithmetic series. Now note that S1, the first term of the arithmetic series, will be the same as the first term of the sequence, T1. S2 would be T1 plus T2. S3 would be T1 plus T2 plus T3. And we should notice from this that if we subtract, for instance, if we have S3 and we take away S2, so S3 minus S2, that leaves us with T3. Have a look at that. S3 minus S2 leaves us with T3. So we can subtract two terms of an arithmetic series to get the term of the arithmetic sequence. So in general, if we're given Sn and we want to find Tn, so if we're given the general term even of an arithmetic series and we want to find a particular term, or we want to find Tn, then Sn minus 1 will give us Tn. Let's look now at finding the general term for the arithmetic series. So Sn is n over 2 multiplied by 2a plus n minus 1 times d. And this formula, just like the one for the term of the arithmetic sequence, can be found in our tables. We'll take a look now at some examples. We'll take this question 1 out of our exercise and we'll look at part 4 here. So we are asked to find Sn, that's the general term of the arithmetic series, and then S20, one particular term. What will we get when we get to the 20th term of the series? And we will have a look at, say, part 4, as we say. So in part 4, we can start out by writing out minus 7 minus 3 plus 1 plus 5 and so on. And just as before, we identify the first term, so very easily. The first term is minus 7. And then we identified the common difference. So we went from minus 7 to minus 3. So that meant we were adding 4 on. So the common difference is 4. And then we just use the formula. Sn is n over 2 times 2a plus n minus 1 times d. Sn is equal to n over 2 times a, which is minus 7, plus n minus 1 times d, which is 4, minus 14 plus 4n minus 4, minus 18 plus 4n. And then we can just divide across by 2, or divide the right hand side by 2, so n times minus 9 plus 2n. And finally we get Sn is equal to minus 9n plus 2n squared. Sometimes we write the n squared term first. And now to find S20, we just put 20 in for n. So S20 is 2 times 20 squared minus 9 times 20. So 2 times 400 minus 180. So that's 800 minus 180, which is 620. So S20 is 620. In the example above, if we look at part 1, we want to find the sum of this series, but we notice that this series goes 6, 10, 14, 18 and so on. If we examine this series, we see that the first term is 6, and we can quite quickly see that the common difference is 4. But we also need to see, when did we add 50? So how many terms of the sequence were there to get to 50? Because remember, the series is got by adding the terms of the sequence. So if we look at the general term of the sequence, Tn is a plus n minus 1 times d. And we know that a is 6, so the general term is 6 plus n minus 1 times 4, just 6 plus 4n minus 4. In other words, the general term is 4n plus 2, and we want to know when is that equal to 50, because we want to know when we got to 50. So 4n plus 2 is equal to 50, so 4n is 48. So this means that n was 12. So we now know that we want to get to the 12th term. We now know there are 12 terms in this series. In general, we know that the Sn is n over 2 times 2a plus n minus 1 times d. And we want to now find S12 because there are 12 terms. So 12 over 2 into 2 times a, which was 6, and n minus 1, so 12 minus 1 is 11, times d, which is 4. So S12 is 6 times, 2 6s are 12, plus 44. So that's 6 times 56, which is 336. And that means that if we add up all this, if we get to the sum of the terms of this series, they'd add up to 336.